Okay, at this point, we've completed the table with the information, the dimensions and area for all of the example parallelograms. We've taken the time to look over those values and try and establish a connection between the dimensions of the parallelogram and the area of the parallelogram. And at this point, we should also have submitted what we believe will be a formula that will work for finding the area of a parallelogram. So at this point, what we're going to do is we're going to look at the values. I'm going to talk a little bit about them, and then we'll check to see whether or not we had the formula or a formula that will work for us. When looking at the table, the values in the table, the thing that would be most important to see is that there's a connection between the base, the height, and the area. Specifically, if we take the base, multiply by the height, that gives us the area. 12 times 3 is 36. 10 times 8 is 80. 7 times 4 is 28. 15 times 6 is 90. 8 times 8 is 64. So every time we have the base and the height and we multiply, we get the area of the parallelogram. It's important to note that the side is not used in the calculation for the area of a parallelogram. So you have an extra dimension there. That dimension, the length of the side, will not be used to calculate area. It will be used to calculate perimeter, but not area, and that's what we're considering right now. So the formula then for the area of a parallelogram would be A equals B times H. Area equals base times height. If you haven't recorded this in the notes section of your binder, now would be an excellent time to do so. We're going to look, because that formula sounds familiar, and that formula sounds the same as the formula for the area of a rectangle. So why do rectangles and parallelograms share the same area formula? Well, they're based on the same characteristics, and that is the opposite sides being parallel, opposite sides being the same in length. If we take a saw or some kind of scissors or whatever and cut a triangular section off the end of a parallelogram and move that to the other end of the parallelogram, we can see that parallelogram essentially makes a rectangular figure, right? So the characteristics of the parallelogram and the rectangle make them similar. In fact, rectangles are a type of a parallelogram, so it makes sense that they would have the same formula for finding the area. That's about it, and now we'll do some practice.